Every minute these machines stop, entire operations collapse. Mines flood, crews idle, millions vanish. These aren't machines built for convenience. They're built for places where failure simply isn't allowed. Here are the machines that work around the clock in some of the harshest environments on the planet. 8. Volvo EC950F. Most hydraulic excavators slow down when temperatures drop below freezing. Hydraulic fluid thickens. Cylinders resist. Cycle times stretch out. That's a problem in Scandinavian quarries where winter shifts run 18 hours and stopping to warm up equipment isn't really a choice. The Volvo EC950F was designed specifically to solve that problem. High-volume earth moving in sub-zero climates. The machine runs a 603 horsepower Volvo D16J engine. But the interesting part isn't the power, it's the eco mode. Volvo traded some peak output for roughly 20% better fuel efficiency, which means operators can finish an 18-hour shift in frozen conditions without needing to refuel mid-cycle. That matters when your refueling depot is miles away and temperatures are sitting at -20 Celsius. Bucket capacity goes up to 9.16 cubic yards, and the hydraulic system delivers 4,980 pounds per square inch of boom pressure. The hydraulics stay active even when the oil wants to turn into sludge, which gives it serious digging force in frozen ground. But there are trade-offs here. The EC950F uses retractable tracks, which improve transportability but sacrifice some of the maximum width stability you'd get from a fixed undercarriage. The boom design prioritizes durability over lightweight mobility. This thing is built to last, not to dart around a job site. In Norwegian and Swedish quarries, operators talk about working through 12-hour nights where the cab heating is the only thing between them and frostbite. Downtime in those conditions doesn't just mean lost productivity. It means frozen stockpiles that block access roads and equipment that won't restart without serious intervention. The EC950F keeps moving through all of it, and that reliability is worth more than any spec sheet number. 7. Liebherr R996B. Take a diesel engine to 16,000 feet above sea level and it starts gasping. Oxygen levels drop. Power output falls. Components wear faster because everything is working harder just to maintain baseline performance. Liebherr R996B operates in conditions most excavators would struggle to handle. This machine weighs 671 tons and carries a bucket that holds 36 cubic meters. It uses a closed hydraulic circuit, which means the system recirculates fluid more efficiently and reduces heat buildup. Cycle times stay fast even at extreme elevation, and service intervals are stretched out intentionally. Liebherr designed this for uptime, not for frequent checkups. They claim around 95% availability, which at that altitude is remarkable. The engineering compromise here is weight versus speed. The R996B is heavy, deliberately so, because stability matters more than mobility when you're digging in thin air and can't afford to reposition constantly. It doesn't have the advanced monitoring systems you'd find on some Komatsu models, but it compensates with robust gearing and high-altitude power kits that help the engine retain output when the atmosphere isn't cooperating. One unit at Veladero reportedly ran for years without a major failure. That's critical because when this machine goes down, haul trucks stop moving. And at 16,000 feet, stranded equipment means stranded crews working 24/7 rotations in an environment that's already pushing human limits. The machine has to work because the alternative is too expensive and too dangerous. If you're here for breakdowns of how machines actually perform under extreme operational constraints, subscribe. We're not here for hype, just the engineering that keeps production running. 6. Komatsu PC7000-11. Loading a 400-ton haul truck with a massive excavator sounds straightforward until you realize the operator can't actually see half of what's happening. Blind spots are a serious problem in open-pit mining, and the Komatsu PC7000-11 was built to address that with ComVision, a 360-degree camera system that gives operators full situational awareness. This machine is a 690-ton backhoe that runs dual 1,500 horsepower engines for a combined 3,350 horsepower. The bucket holds 38 cubic meters, and the hydropilot system prioritizes hydraulic flow to keep cycles smooth and predictable. It's designed for Tier 4 final emissions, which matters in jurisdictions that actually enforce air quality standards around mining operations. The hydraulic system is open circuit, running at 4,495 pounds per square inch. Open circuits are easier to cool and filter, which is important when you're working in dust-choked environments. There's also an electric drive option that boosts reliability by reducing the number of mechanical components that can fail. Safety features include automatic lubrication and a low vibration cab, because operators are sitting in this thing for 20-hour shifts. In large open pit mines around the world, the PC7011's data analytics help prevent failures before they happen. The system can detect hydraulic overheating and alert the operator before damage occurs. That's not just convenient, it's essential. When this excavator breaks down, the entire fleet idles, and that can cost upwards of $100,000 per hour in lost production. Operators depend on it because there's no backup plan. 5. Demag H740OS. Canada's oil sands are brutal on equipment. The bitumen is sticky, abrasive, and difficult to extract. It gums up machinery and resists conventional digging methods. The Demag H740OS was purpose-built for this environment. A 744-ton diesel-electric hybrid that uses electric drive to deliver torque without the heat buildup you'd get from a purely diesel system. The hybrid setup trades battery weight for lower emissions and better efficiency during 20-hour shifts. Electric drive gives you instant torque, which helps when you're trying to penetrate terry piles that conventional excavators struggle with. The buckets are specialized for sticky loads, designed to release material without constant manual intervention. The HST transmission prioritizes tractive effort over top speed. This isn't a machine built to move quickly. It's built to dig deep into stubborn material and keep doing it without overheating. Operators in Alberta work in extreme cold, but the hybrid system includes redundancy. If one power source underperforms, the other compensates. Failure in the oil sands doesn't just mean downtime. It means encrustation. Material hardens around the equipment, and you're looking at hours of cleanup before you can even start repairs. Syncrude's operations have shown what happens when machines can't handle the conditions. The H740OS was engineered specifically to avoid those scenarios, and it does. 4. Hitachi EX8000-7. In deep open-pit copper mines, every time you reposition an excavator, you lose time. The Hitachi EX8000-7 addresses that with extended reach and a 52 cubic meter bucket. Fewer swings, fewer moves, more material moved per cycle. It operates in Chile's copper mines and Alberta's oil sands, places where the pits are so vast that repositioning delays add up fast. The hydraulic system delivers 5,000 pounds per square inch at 4,500 liters per minute. That's massive flow, and it comes with a trade-off. Efficiency takes a slight hit in favor of cycle speed. In dusty, toxic environments, speed matters because extended exposure means more wear on filters and components. The HVI monitoring system predicts wear patterns and alerts operators before failures occur. There's a story from an African dam project where an EX8000-7 prevented significant delays because it kept running when other equipment failed. That reliability mattered because operators working at height on unstable ground can't afford to be climbing around broken machinery. The machine worked 24/7 and the project stayed on schedule. 3. Komatsu PC8000-11. The Komatsu PC8000-11 runs 2 engines, each producing 2,010 horsepower, for a combined 4,020 horsepower. But the real engineering here isn't the power output, it's the redundancy. Each engine drives an independent hydraulic circuit through 8 swash plate pumps at 4,495 pounds per square inch. If one engine fails, the other keeps the machine operational. Bucket capacity ranges from 42 to 55 cubic meters depending on configuration, and the machine can move 6,800 tons per hour when everything's running smoothly. The trade-off for redundancy is weight. Dual engines and independent hydraulic systems add mass. But in harsh mining environments, zero downtime capability is worth the extra tonnage. The open hydraulic system cools the swing circuits efficiently, which reduces thermal stress during long shifts. For operators, this design reduces stress in a different way. When you're working a remote site and the nearest backup equipment is days away, knowing your excavator can limp along on one engine if needed is a genuine relief. Breakdowns here don't just stop one machine. They cascade through the entire fleet. What machine has impressed you most so far? Drop a comment below, and if you haven't already, subscribe. We break down real machines, real output, real trade-offs. 2. Liebherr R9800. Hydraulic excavators waste energy every time they swing. The boom moves, momentum builds, then it stops and all that kinetic energy dissipates as heat. The Liebherr R9800 addresses that with regenerative hydraulics that recapture swing energy and feed it back into the system. It's operating in Indonesia's East Kalimantan coal mines, moving overburden with a 57.5 cubic yard bucket on an 882-ton frame. The machine loads 3,750 bank cubic meters per hour. Service intervals are long, which favors uptime over frequent maintenance checks. The trade-off is scale. This machine doesn't move quickly, but it doesn't need to. Fewer passes mean less repositioning, and in wet, muddy conditions, every avoided move is time saved. At KPC Mines, the R9800 works through the monsoon season. When it rains heavily in Kalimantan, pits flood. If the excavator goes down, water accumulates faster than pumps can handle it, and you're looking at days of recovery work just to restart operations. Operators work endless shifts during monsoon season because the machine has to keep moving material, or the entire site becomes waterlogged. The R9800 keeps running, and that's not marketing. It's operational necessity. 1. Caterpillar 6090 FS. The Caterpillar 6090 FS weighs 1,102 tons and uses a 103-ton bucket to load 400-ton haul trucks. At that scale, precision becomes difficult. Spills waste material and time. Overloading damages trucks. The 6090 FS uses load-sensing hydraulics and rollback limiters to prevent both problems. The hydraulic system is optimized for flow. Caterpillar cut the oil needed for boom lift operations roughly in half compared to older designs. That's not about saving hydraulic fluid. It's about reducing cycle time and thermal load. The system prioritizes precision over raw power, which at ultra-class scale is the harder engineering problem. Durability comes from high-strength steel construction. In supersized mining operations around the world, the 6090 FS runs 24/7 with a closed swing circuit that maintains consistent performance regardless of ambient temperature or dust levels. Downtime at this scale can mean multi-million-dollar losses, and operators working isolated sites trust the machine's automated features to compensate for the limits of human endurance during extended shifts. So, which among these machines fascinated you the most? Drop your thoughts in the comments below. If you found this breakdown valuable, subscribe for more content like this and check out our previous video on the 15 biggest tractors and farming machines. That one covers a different side of heavy equipment, but the principles are similar. Or you can watch this video right here that YouTube thinks you would enjoy. Happy binging!